Today, everyone, for today's video, our focus is on finding the critical value as well as the critical point of your function. And we will also use the first derivative test in determining what interval your function is increasing or decreasing. And we will also use the second derivative test on testing the concavity of your function. And lastly, we will discuss about the point of inflection. Okay, let us start with a given function. Say we are given with a function, let us have a function, say f of x. F of x is equal to, say, x cubed minus 3x squared plus 5. And we are asked to find those four. So the very first thing is we're gonna be determining the critical value of our function, and we will be able to find that critical value if we take the first derivative of your function. So what we will have here is we will have the first derivative of your function. So here we will just use the power rule. So the derivative of x cubed will only be 3x squared, and the derivative of this will only be negative 6x, and the derivative of 5 is a constant. And then the next thing is in finding the critical value of your function, all you have to do is to determine what or when your function is equal to 0 and when your function is undefined. But in this case, since you don't have variable in your denominator, so all you have to do is you just have to take the case wherein your function becomes 0. So if there is a variable in your denominator, you will also equate that one into 0 because that makes your function undefined. Okay, so here we will equate this 1 into 0. So we will factor out this. So maybe we will factor out 3x. So what is left here is only x, and here is only negative 2. So after that, we will be solving for x. It will give us x equal to 0, and here x is equal to 2. And these are the critical value. So this is what we call critical value. So out of our critical value, we will also solve for the critical point. Of course, we will just have to find the corresponding y in each x here. So if we substitute it back to the given, if x is equal to 0, so it becomes 0, 0, then 5. So your y here is 5. And the other one, when your x is 2, it will be 2 cubed. The 2 cubed is 8. You have there 8. Then minus 3 times 4 plus 5. And then it will be 8 minus 12 plus 5. So it will be 13 minus 1. So it will be 1. Y is equal to 1. So your critical points now are critical points are, so the critical points here are the points 0, 5 and 2, 1, right? Again, let us write here the critical points are 0, 5, and the other critical point is the 2, 1. Okay, so what's the use of this critical value? Actually, the first derivative test. The first derivative test will tell us what interval your function is increasing or decreasing. And we will be using our critical values here. Let's plug in into the real number line. We have here 0 and we have also 2. So there are intervals that we're gonna be looking at. We have the negative infinity to 0, 0 to 2, 2 to positive infinity. So what we will do here is we will just get testing points from each interval. Say, let's get here negative 1. If we test negative 1 in our first derivative, so if you substitute it here, it becomes f prime of negative 1. So if we're going to substitute it here, and we will be looking for the sign, it will be 3 times the negative 1 squared minus 6 times negative 1, negative 1. So here it becomes positive 1, so it's a 3. Negative times negative, it's positive 6. So obviously, this is a positive 9, so it's a positive here. So, by the way, if the first derivative, if this this testing point is positive in that first derivative, then your function in this interval is increasing. Okay? While if we get, let us get another testing point from other interval. Okay, let's erase this first. So in between 2 and 0 and 2 is we can have their positive 1. So if we will use positive 1 here, so if we will test that in the first derivative, so f prime of positive 1 this time, so you have 3 times positive 1 squared minus 6 times positive 1. So it becomes 3 minus 6, and obviously this is negative 3. So in this case, here is negative. Since it is negative, from the first derivative test, your function in this interval from 0 to 2 is decreasing. So let's have the last interval. And as you look at there in the last interval, we can get, say, any number that that is part of the interval from positive 2 to positive infinity. So shall we get positive 3? So if we get positive 3 here, we get positive 3. So you will now have f prime of positive 3, and it will be 3 times the positive 3 squared minus 6 times positive 3. So obviously this becomes 9 times 3, 27 minus 18, and it is very clear that this is positive. So in this case, your function, in this interval rather, your function is increasing. Okay, so that's the use of the first derivative test. The first derivative test will tell us whether your function is increasing or decreasing into a certain interval. Okay, so as we consider here, so if we will imagine your function here is increasing. So if you say increasing, the slope of your line or the tangent line of that curve must incline to the right. So it will look like this, right? And in this interval from 0 to 2, it is decreasing. So the slope is inclining to the left. So it will look like this. So if you pick this point here, this point 0, 5, as we can see, this is 0, 5. We will plot it in the Cartesian coordinate plane. The point 0, 5 is what we call the relative max. Relative, relative max. Okay? Relative maximum. And if we consider in the other side here, so the graph in this interval is decreasing. If you say decreasing, it's going down. While here, it's going down. While in this interval, your function is increasing. So if you say increasing, the slope of that is obviously inclining to the right. So it will look like this. So on this point, that point 2, 1, is somehow we call that as relative minimum. Okay, relative minimum. So that's the use of the first order derivative. We will be able to know whether the critical point that we have here is a relative max or a relative min. And actually, we can we can affirm this later by using the second derivative test, the testing of concavity of your function. Okay, so have let us test the second derivative. Let's have the second derivative test. So if we're gonna consider the second derivative test, and it will goes like this. So all you have to do is you just have to take the derivative again of your first derivative. So if you get the derivative of this function, f prime of x, so obviously this becomes 6x. This becomes negative 6. Okay, and after that, all you have to do is to equate it again into 0. The same process what we did in finding the critical value. So it becomes 6 minus 1 equal to 0, or somehow x here is equal to 1. So if you will plot here in the Cartesian plane, so or even here, you can use it here. Okay, let's use red. If you can plot it here, this point, oh, it's not red here. If we plot this point, that value rather, this value is is the one that we are going to use in determining what interval is your function is concave up or concave down. So what we will do here is we will the same thing. We'll get a testing point out of the interval. So as you can see in the interval that we have here, we will have two intervals only because we only have one 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 point here, one value. So we will have negative 1 to positive 1 and positive 1 to positive infinity. So we will check 0 because 0 is in it, is in the interval. So it becomes if we substitute 0 in the second derivative, so obviously it becomes negative. By the way, if the second derivative of your function will give us a negative values, then your graph is concave down, just like what we have here. It's concave down. So if we will get also a testing point in this interval, say we will get 2. If we substitute here, it becomes 12 minus 6, that's positive. And if we consider that positive, so it's concave up, just like what we have here. So that is what we call the the this concavity of your function. It's concave down here and concave up here in this interval. And if you're gonna be finding the corresponding y value of your function, say we will have we will substitute it back to the original. So it becomes 1 cubed minus 3 times 1 squared plus 5. So it becomes 1 minus 3. So that's negative 2 plus 5. So that will give us 3, right? So your y is equal to 3. So at the point 1, 3, this point 1, 3 is what we call the point of inflection. What is point of inflection? The point of inflection is the point wherein your concavity changes its direction. It's coming from concave up, it changed to concave down, or concave down going to concave up. So if we will graph our function, actually, this is the best technique in graphing your function. If you don't have a graphing calculator, if you cannot use Desmos in graphing your function, you can use second derivative and first derivative in finding the graph of a given function. So if we're gonna be looking for the graph of this function, say this function, so what we will have, let me erase it first. If we will erase this, it will goes like this. One, wait for a while, give me a few seconds. Okay, here. So let us have Cartesian coordinate plane here. First, what we will do is we are going to locate our critical point that we have, the 0, 5. The 0, 5 is somewhere here. And we will also have the critical point 2, 1. 2, 1 is somewhere here. Okay, so we will also have our point of inflection that is 1, 3 somewhere here. So as you can see here, our function from the interval from negative infinity to 0, from negative infinity to 0, your function there is increasing. So if it is increasing, the slope is somehow inclined to the right. So it will goes like this, right? So your graph is somehow a curve that goes like this. And for the interval from 0 to 2, from 0 to 2 here, your function is decreasing. So it will goes like this. It will pass through that point. It's a curve. Maybe it will not look like a curve, but it's really a curve. And then from the interval from 2 to positive infinity, your function is increasing. So it will goes like this. And aside from that, using the second derivative test for the concavity of your function, from the interval negative infinity to 1, from negative infinity to 1 here, your function is concave down because the second derivative is negative. And from the 1 here until the positive infinity, your function is concave up. And as you can see, if we look at, if we are going to look into our what we call point of inflection, it's the point where your function changes its concavity. Yes, it's this point that we have lighted color here. So this is the point where your concave down changes into concave up. So that's it. Finding the critical value, the test derivative test, the second derivative test, and the point of inflection. So I hope that you learned something today, and see you again for the next video, the continuation of this, wherein we will apply it into real life problems. See you again for the next video. Have a nice day.